In this video, we're going to create our moving object class. This is going to be a class that's going to provide the movement functionality for both our player and our enemies. We're going to share functionality between those two unit types by causing their classes to inherit from moving object. We're going to create a new C# script called moving object. And open it in MonoDevelop. The first thing that we're going to do in moving object is we're going to make it a public abstract class. The abstract keyword enables us to create classes and class members that are incomplete and must be implemented in the derived class. Next, we're going to declare our public variables. We're going to start with a public float called moveTime, which is going to be the time that it will take our object to move in seconds. We're also going to declare a public variable of the type layer mask called blocking layer. This is going to be the layer on which we're going to check collision as we're moving to determine if a space is open to be moved into. You may remember that we placed our player, enemies, and walls on this layer when we were creating our prefabs. Next, we're going to declare some private variables. We're going to declare a box collider 2D called box collider. We're going to have a variable of the type rigid body 2D called RB2D. We're also going to have a private float called inverse move time. We're going to use RB2D to store a component reference to the rigid body 2D component of the unit we're moving. And we're going to use inverse move time to make our movement calculations more efficient. We're going to modify our start function to make it a protected virtual void start. We're doing this because protected virtual functions can be overridden by their inheriting classes. This is useful if potentially we want one of the inheriting classes to have a different implementation of start. Next, we're going to get a component reference to our box collider 2D and store that in box collider. In start, we're going to get a component reference to our rigid body 2D. We're also going to set inverse move time to 1 divided by move time. By storing the reciprocal of move time, we can use it by multiplying instead of dividing, which is more efficient computationally. Next, let's declare our smooth movement coroutine. We're going to use this coroutine for moving units from one space to the next, and it's going to take a parameter called end to specify where to move to. The first thing that we're going to do is we're going to calculate the remaining distance to move based on the square magnitude of the difference between the current position and our end parameter. We're using square magnitude because it's computationally cheaper than magnitude. Next, we're going to do a while loop which checks that our square remaining distance is greater than float.epsilon, which we're going to use for a very small number, almost 0. In our while loop, we're going to find a new position which is proportionally closer to the end based on the move time. We're going to do this using vector3.moveTowards. We're going to pass in the position of our rigid body 2D as the first parameter, the end, which is the position that we're trying to move to, and then inverse move time multiplied by time.delta time. Vector3.moveTowards moves a point in a straight line towards a target point. In this case, the point that we're moving is going to be new position, so we're setting new position to the value returned by vector3.moveTowards, and we're going to move between rb2d.position, our current position, the end, which is our destination. The value returned by vector3.moveTowards is going to be a point, which in this case is going to be inverse move time times time.delta time units closer to our end destination. Once we've done that, we're going to use move position on our rigid body 2D to move to the new position that we found. Next, we're going to recalculate the remaining distance after we've moved. Finally, in our while loop, we're going to yield return null, which means that we're going to wait for a frame before reevaluating the condition of the loop. We can delete our update function. Next, we're going to declare our onCan'tMove function. OnCan'tMove is going to be a protected abstract function that returns void and takes a generic parameter t as well as a parameter of the type t called component. Here, the abstract modifier indicates that the thing being modified has a missing or incomplete implementation. OnCan'tMove is going to be overridden by functions in the inheriting classes. Notice that because OnCan'tMove is an abstract function, it has no opening or closing brackets. And next, we're going to declare a protected function called move, which is going to return a Boolean and take parameters of the type int called xdir and ydir, and also a raycast hit2d called hit. The out keyword causes arguments to be passed by reference. In this case, we're using it to return more than one value from our move function. We have the Boolean value, which is the return type of the function, and then we're also returning our raycast hit2d called hit. In move, we're going to start by declaring a vector2 called start and using that to store the current transform position. Transform.position is a vector3, but by casting it to a vector2, we can implicitly convert it, discarding the z-axis data. Next, we're going to declare a vector2 called end, and we're going to use that to calculate the end position based on the direction parameters passed in when calling move. We're going to disable the attached box collider 2D to make sure that when we are casting our ray, that we're not going to hit our own collider. Next, we're going to cast a line from our start point to our end point, checking collision on blocking layer. We're going to store the return value of that in hit. And then we're going to re-enable our box collider. Next, we're going to check if anything was hit by checking if hit.transform is equal to null. If hit.transform was equal to null, meaning the space that we cast our line into was open and available to move into, we're going to start a coroutine called smooth movement, passing in the parameter end. Next, we're going to return true to say that we were able to move. If hit.transform equals null is false, we're going to return false to say that move was unsuccessful. The next thing that we're going to do is declare a function called attemptMove. This is going to be a protected virtual function that returns void and takes a generic parameter t. It's also going to take two integer parameters for x direction and y direction. The generic parameter t is used to specify the type of component we expect our unit to interact with if blocked. In the case of enemies, this is going to be a player, and in the case of the player, this is going to be walls so that the player can attack and destroy the walls. We're going to use the where keyword to specify that t is going to be a component. Inside our function, we're going to declare a raycast hit2d called hit. Next, we're going to declare a Boolean called canMove, and then we're going to call our move function and set canMove to the return value of move. This means that we're going to set canMove to true if move was successful and false if it failed. The fact that hit is an out parameter for move is going to allow us to check if the transform that we hit in move is null. This means that if nothing was hit by our line cast in move, we're going to return and not execute the following code. If something was hit, we're going to get a component reference to the component of type t attached to the object that was hit. If canMove is false, And hit component is not equal to null, meaning that moving object is blocked and has hit something that it can interact with, we're going to call the onCan'tMove function and pass it hit component as a parameter. Let's hit save. The reason that we're using the generic parameter here is because we're going to have our player and our enemy inherit from moving object. So player is going to need to be able to interact with walls, and the enemy is going to need to be able to interact with the player. This means that we don't know in advance what type of hit component they're going to be interacting with. By making it generic, we can get a reference to it and pass that into onCan'tMove, which will then act accordingly based on the implementation of onCan'tMove in the inheriting classes, which we're going to write in the upcoming videos. Before we move on to writing those scripts, however, we're going to set up the script for our wall objects in the next video.